Aerospike Summit 2021. My name is Micah Carrick, and I'm an architect and a consultant with Aerospike. I work with a number of our enterprise customers as well as with our managed services team, which is the team that deploys and operates Aerospike clusters on behalf of our customers in the public cloud. I do spend a lot of time consulting and working in the security and data privacy space. It's a bit of a subject area of interest for me. So I'm happy to take you through a few of the things that you should be thinking about in order to secure your Aerospike clusters. So with that, let's jump into my presentation. Okay, so to start, we're going to talk about how you secure your network. In Aerospike, there's effectively 3 to 4 types of network connectivity you need to protect, depending on whether or not you're using our cross data center or XDR feature. So the first thing is applying your firewall rules. In this case, I'm going to kind of assume a least privilege model, which means that the firewall does not allow any traffic, or it blocks or denies all traffic, and you need to allow traffic for Aerospike to function correctly. The first type of traffic that you'll want to allow is what we call the service traffic or service port. This is TCP traffic, where Aerospike is available to client applications to do your standard database operations. This is where you're doing reads and writes. This is also where a monitoring stack might be getting metrics, or an administrator might be issuing commands to the database. That's all the service port. And so that's going to be going from your applications or any tools, any servers running tools you're running, to the Aerospike nodes themselves. Now, what's notable about this traffic is that every single application node should allow TCP connection to every single Aerospike node. And this is how the Aerospike cluster works. The application nodes talk directly to the Aerospike node that has the data it's interested in. So this is typically as simple as a rule that allows the application subnet to initiate TCP connections to the Aerospike database subnet. The next 2 types of traffic are Heartbeat and Fabric. Heartbeat is our clustering protocol. This allows the database nodes to exchange information with each other about the cluster so that the cluster can respond to a changing cluster size. Maybe a node died, maybe you've added 3 more nodes to the cluster, that type of thing. The Fabric traffic is where data is replicated between nodes, and that can happen as part of a write, where it's replicating that write as backup copies, or it could happen when the cluster is going through some sort of change. Again, maybe a node died, maybe you added some nodes. It would redistribute the data over this Fabric connection. So both of these are node to node. They don't need to be opened up outside of the subnet that Aerospike is running in. It just needs to allow every Aerospike node to initiate TCP connections on these 2 ports to every other node. And then the final type of traffic, again, this is only if you're using our cross data center replication, which means you're replicating data asynchronously to another Aerospike cluster in a different data center or different cloud region. Now, with that type of setup, you would have a traffic going out of the Aerospike nodes and to another Aerospike cluster that uses the service port, just like applications. So from a firewall rule perspective, it looks just like just like the other service traffic, with the difference being that it's originating from the source cluster. Now, all of these ports are configurable, but by convention, we use port 3000 for service, 3001 for Heartbeat, 3002 for Fabric. And again, that's configurable, that's just a convention, but that is what you'll see in most of our example code and documentation. Once you've got your firewall rules set up so that traffic can flow for the Aerospike deployment, but only absolutely what is necessary. The next thing is to encrypt the data that's in transit. So this means you're going to be installing and configuring TLS. Now, with Aerospike, you can configure TLS independently for all 4 of those types of traffic that I mentioned in the previous slide. However, it does allow for some very specific use cases or adhering to some very specific security requirements. The typical setup would be to use the same certificate for the Aerospike server, and then if you're using something called mutual authentication TLS, then you would have another certificate and key pair for the application nodes. So to talk about that a little more, we support two modes between the application and the Aerospike database. So that's the service traffic. Standard authentication would mean you have to install a TLS certificate and private key on all of the Aerospike server nodes. This is a certificate that will be presented to the client when it's connecting, and it'll be sort of cryptographically verifiable that the server is in possession of that private key, and that gives the client some assurance that it's not talking to some bad guy in the middle, no man in the middle attack. With mutual authentication TLS, it adds on to that a key and certificate on the application nodes, so that the server is also validating that the client is providing proof of possession of that private key. So it basically means both sides are verifying and authenticating. And that is pretty common in enterprise use cases where sensitive data or compliance are a requirement to have the mutual TLS, or MTLS as it's often abbreviated. The heartbeat and fabric, again, this is the node-to-node communication on the server side. This is effectively mutual TLS, kind of out of the box, just in how it functions. The nodes will exchange TLS certificates with each other, and sometimes a node is initiating traffic, sometimes a node is receiving traffic, so it kind of goes both ways. This could be configured separately, but it's much more typical to simply configure the entire cluster to use one public and private key pair. The applications use another, and regardless of how many nodes they are, they're using the same TLS certificates and keys. And then finally with XDR, it's the same sort of pattern, again, as an application would be. XDR is using the service traffic, so you would configure your source cluster like a client. So with mutual authentication TLS, that means it's going to have the certificate and private key as a client certificate. The destination cluster is presenting its certificate as the server, the TLS server in that paradigm. So the other thing I'll mention about TLS real quickly is selecting cipher suites. These are the algorithms that the two sides are going to negotiate and agree upon using. Now, with public applications, internet-facing web applications, for example, you often have to support a very long list of cipher suites so that you can ensure you have compatibility with the different user agents. An old browser might not be able to support the newer, more secure, more performant algorithms. In the case of something like a database, in the case of Aerospike, you typically control the application and the database server, so you can actually be very fine-tuned with the cipher suites you want to support. With TLS 1.2, it's generally AES, either 128 or 256. There's CPU acceleration for those algorithms. It's very performant. It's also very secure. So using the sort of top three algorithms, or even the very specific algorithm that you want to use, is very viable for an Aerospike deployment. Next, so the network is secure. Now we need to talk about securing access to that database. Who can access that database on those secure network channels? So Aerospike actually supports two modes of authentication. We're going to look at a third version here, which is a hybrid of the two. But first, think about both humans accessing the data and applications accessing the database. Even though it's going to be the same technology or the same configuration that allows this to happen, there is a small difference. Humans accessing the database are typically administrators. It might be a sysadmin who's looking to get more verbose logs, or it may be a data administrator who's looking to set up indexes or manage scans or something like that. So these are people doing an operation on the database, typically somewhat out of band. Applications, on the other hand, this is potentially a real-time, always-on application that's continuously accessing the database, and it probably also has its own access controls once it's in production for who and how can interact with that application. So this presents slightly different properties for these two types of authentications to the database. Aerospike's default sort of out-of-the-box internal authentication is shown on the left side here. This is your typical username password that everybody's used to. It's very fast, it's very easy, but it does have a problem in that you have credentials now stored in Aerospike database, and for an enterprise with thousands of systems or tens of thousands, you try to avoid that sort of credential sprawl everywhere. So you want to get those credentials out of Aerospike and into your central employee directory, especially for those human users. So the middle part of the slide here is showing our external authentication. And in this mode of authentication, the Aerospike server is going to check the credentials against your own employee directory. So that could be Okta, that could be Ping, that could be Active Directory, that could be Google's G Suite, whatever it is. There's an external centralized directory of employees and their credentials and what they have access to, and Aerospike can use that via LDAP. So this is very common, very, very popular for that human authentication. But one of the challenges, if you have applications that are connecting to the data and they're always on, they're mission critical, whether or not your LDAP infrastructure is able to sort of meet those same requirements may or may not be true. So another pattern that's quite popular is to use that employee directory, and this is the third one on the right. Use that employee directory for human users, for the employees, and administrators authenticating with Aerospike, but then let the applications use Aerospike's internal authentication so that there is no third system that's in critical path for those applications to function. You can expand on that a little bit by using some secrets management to manage the lifecycle of the credentials in Aerospike. So something like HashiCorp Vault, where the applications get the credentials from HashiCorp Vault and then use that to talk to Aerospike. And then a separate sort of out-of-band process, HashiCorp Vault, is renewing or refreshing or dynamically generating those credentials in Aerospike so that there's no tight coupling of the application to credential management and these Aerospike clusters. And it also gives you some of that same properties of having a central system. The good thing about that is if that system, or those systems typically are designed to be always on and highly available. So once you know who the user is that's trying to authenticate, you'll typically be restricting them down to only access the things that they need in order to do their job. And that's true for both humans and applications. So this slide here shows sort of Aerospike's access controls, just as a hypothetical example. The top three are human users, the bottom three are applications, and you can see there's permissions that sort of give that user the ability to do certain things and a scope, and we can even go and restrict access to perform those operations only when connecting from a specific range of IP addresses. So just to take a couple here, you can see the Acme DBA, that would be like a data administrator, and they would be doing things again like managing scans or creating indexes, and they can do that across the database. Whereas if we then look at Acme application number 2, app 2, it has a read-only access and to a specific namespace and a specific set. So in Aerospike, if you're not familiar, a namespace is effectively a configuration of the storage tier. It's where the data is actually being stored on the nodes themselves. So it determines things like indexes and data being stored in RAM or persistent memory or SSD or file system. Those are sort of what it gets configured at the namespace level. So it's kind of a self-contained database, but there can be multiple namespaces within a cluster. So the paradigm here is kind of showing that Acme App 2 has read-only access because it only needs to read data, and a daily loader has access to write data for that application. So again, it's that least privilege access model. And then now that we've sort of controlled access of who's legitimately accessing that data, you also have to protect the data on the servers themselves, so physically protect the data. And in Aerospike, I mentioned before these namespaces that we're scoping access to. They also have some neat properties when you're thinking about how you're configuring the storage layer. Um, so namespaces not only define where is that data physically being stored on the server, but they also allow you to encrypt the data at rest with AES 128 or 256-bit encryption. What's nice about that encryption being at the namespace level is you can get a good degree of logical separation, or you could even go all the way down the path of complete physical separation with separate encryption keys. And where this might be useful is if you have different classifications of data or you have different use cases and you want to encrypt them separately and control access to them separately, just to reduce the blast area of a potential breach. So the slide here is showing that there's two physical SSD volumes or SSD drives attached to the server, and they're partitioned into a total of 4 logical partitions. So you're able to basically stripe both of these namespaces across all of these devices so you get a nice even utilization, which is convenient for monitoring, convenient for wear and tear, but you still get to logically isolate them and encrypt them. So the namespace 1 in this example, if that encryption key were compromised, it would not compromise the data that's in namespace 2. And that again is giving you that nice isolation and that encryption at rest. Now, while it's great to have the encryption at rest, it's still important to understand that Aerospike, the process, it is a database, it is a privileged process, it is decrypting data from drive, it's potentially manipulating it in memory depending on the operations you're running on it, and then it does get decrypted and sent back over the wire, encrypted with TLS, but it's still in memory, unencrypted. It is still a server that on data, and therefore you really need to protect it as such. So all your typical hardening for OS or container or images or however you're running it, that applies here. It's still important. But what's probably worth calling out is a recommendation to avoid running auxiliary functionality on those database nodes. It may be tempting to run an application on those nodes just to share the server space. That could be convenient or cost effective, but it does pose more risk. There's more libraries that need to be patched that could potentially expose vulnerabilities. It's going to result in more people being able to access those systems, etc. So keep them singular in purpose, keep them a database node, and harden it like you do all of your other hardening. The other thing to note there is Aerospike provides a suite of tools, things like commands asinfo, asadm, AQL. These are convenient commands for operators and admins, and they are bundled with the server. So they are installed on each of these server nodes. There are, in fact, some operations that must be run on the server node for troubleshooting. However, a lot of the functionality of these utilities do not need to be running on the server in order to function. They actually connect to the database just like any other client. So a best practice here would be to actually install the Aerospike tools, which is also bundled separately that you can download for your distribution, and run those on a dedicated server for that purpose. That way you can control access to all of the admins at that node, and then they connect to the cluster over TLS with those firewall rules that we talked about earlier. So you can prevent them from having direct access to the actual instances unless there's a troubleshooting scenario where you're actually troubleshooting the nodes at the hardware level. And then finally, you want to protect the secrets, passwords and keys that are necessary for Aerospike to run properly. The sort of, I guess, classic model would be, the keys are on the file system and they get deployed there using configuration management. Configuration management is pulling those keys from some sort of secrets manager at runtime, and then they get written to the file system, and therefore they're protected using the file system's standard Linux users and groups and SE Linux policies and things like that. What's also worth looking into, especially if you're already either using HashiCorp Vault or looking to in the future. Aerospike does have a direct integration with HashiCorp Vault. What that means is if you have an HA highly available Vault deployment, Aerospike can get the credentials directly from Vault, so no secrets are ever written or persisted to the file system at all. This is a very nice way to do it. It prevents having those secrets in two places. It also kind of lowers the surface area there. However, it does require having Vault available and HA. It does end up being in critical path. Not that Aerospike is calling the Vault on every transaction, but it would be loading those secrets out of Vault when it needs to, for example, when it starts up. So if Vault were down and you were trying to scale out your cluster and it couldn't get those secrets, then it wouldn't be able to scale out. But it is very common these days to have a highly available Vault deployment, and if that is your pattern or somewhere you're looking to go, this is a great way to manage those secrets. If you're not doing that, it's still very viable to use your secrets management in your configuration management step, sort of in that classic pattern I was talking about in the beginning. And the secrets, just to enumerate these real quick, the secrets that you care about protecting, it's those private keys for the TLS certificates. It's the encryption at rest keys, so this is per namespace. It's credentials to the LDAP server if you do have the external authentication. Aerospike is going to be provided with some credentials that allow it to query that system to determine if a user is authenticated or not. If you're using XDR, the Aerospike server will have credentials that it uses to authenticate with the destination cluster. And then there's a folder known as the system metadata folder in Aerospike, and this isn't secrets per se, but I just call this out here to make sure you're protecting it like you are all of the other sensitive data. It would be it's an area you wouldn't want an unauthorized Linux user being able to get into. So keeping that locked down to the Aerospike process is a good idea. And then finally, you're going to want to log and be able to audit security events that are occurring within the database. Aerospike provides a feature known as the Audit Trail. And what this is in addition to our standard system logging, where events that are important from a security context are going to be logged separately. And this is using syslog, so you can point this at a different location. It could go to the same log file, it could go to a different log file, or you could ship it anywhere you want to ship it. So this would be events like, when somebody tries to authenticate and fails. This would be something like somebody authenticating and succeeding. And a lot of these administrative functionality, creating an index, changing the log level, things like that are logged in Aerospike's Audit Trail. Now you can go so far as to even log every read and write operation. However, that's often not desirable simply because of the throughput. If you have millions of transactions per second, that would mean you would have millions of audit log events per second, and that would just be a lot of data to consume in your log ingestion framework. It is possible if you have the infrastructure for that, but more typically it's these admin operations only, and those would be sort of basically the human operations. So what we see here kind of in this slide is how this might be used. You take these audit trail events, you ship them to your downstream system. This may be the same log aggregation framework that you're using for all of your logs, or you may have a dedicated stack just for security events. In either approach, it's kind of the same concept of taking all of these event logs, bringing in some data from other sources, perhaps the applications, and feeding those into a platform where, one, you can do auditing. So in the event of a expected breach, you can look who did what and when. It's also used for real-time analysis. There's patterns that are consistent, and when there's an inconsistent pattern, you can alert a security team and say, hey, something doesn't look right here. A great example of that, and maybe an obvious example, would be those failed login attempt events. If that's happening, several times a second, or even several times a minute for some period of time, that kind of stands out as being a red flag, especially if that user typically logs in once per day at most. So that's how you can leverage Aerospike's Audit Trail feature. and do your sort of security incident and event management on that data. And with that, that concludes this presentation. I know there's kind of a lot of information that you could dig into if you need to. We have a lot of information in our knowledge base articles, on our documentation, our support team's ready to help client services. So hopefully this just gets you started on the right path. And with that, I will take a few questions. Thank you for listening.
Thank you, Micah, for this presentation. So let's see if we have any questions. Otherwise, I have a few of my own. So if nothing comes up here. So first one, so that's something that comes up actually fairly regularly from on the support channel from our customers or prospects. Can you touch on the performance impact of enabling encryption, TLS?
Sure, yeah, and comes up a lot in my world as well on the consulting side, especially around optimizing, right? So TLS is going to work out of the box, it's going to be functional, and if you haven't actually benchmarked with or without, you might not even know what that server could do without. But it's not free, but it is very good. So early in the presentation, talked a little bit about the types of network connections: service, fabric, heartbeat, and TLS being able to be configured on each of those. So for the service traffic, you're generally able to get very good performance for a couple of reasons. One is that you control the app, you control the server, so you don't have to support a bunch of different cipher suites, a bunch of different algorithms, some of which may be old and slow. You can use the newer AES with GSM algorithms that are going to be GCM algorithms that are going to be very fast, and they're sort of the best practice from a security perspective. So you can get a fast algorithm. Modern CPUs for quite some time now have the hardware acceleration to do the AES encryption and decryption on chip. So that's all very good. The thing you do want to consider when enabling TLS from that application to Aerospike service traffic is the establishing an initial connection. Establishing a connection is always a bit expensive, but with TLS even more so, because there's that handshake that occurs. So there's 3 round trips of negotiating what cipher suites do you support, and prove to me that you possess the certificate. So that's more expensive. So you want to limit the amount of connections that you're churning, that you're destroying and then creating new ones. So you want to be not too aggressive with timeouts, and we do have some client-side tuning that you can do for example, pre-allocating the connections that you're going to need. You can do that up front before a node starts taking traffic, and then it's only about the encryption decryption of that already established connection. So that's some tuning you can do on that type of traffic. The other consideration where we might optimize to get more utilization out of a server is on that fabric communication, and that's the data replication. So by default, it's going to be okay, but there's about 4 different knobs we can tune there to try to optimize it for your specific workload to get more throughput out of those channels. And that's kind of a factor of how many nodes you have, what your workload looks like. So it is a tuning exercise where we try some different settings until we get the optimal TPS that we can get out of your server or your hardware.
Thank you. Yeah, the connection churn is a very, very good point. That's something that it's often not thought of, and especially when doing benchmarks and when something especially in the cloud, if there are disruption, anything like that, it can quickly then expose some of the things that could be tuned better to try to limit the connection churn. Thanks.
Exactly.
So great. So we have a couple of questions. So, are there tools to help with this subject? So this is a pretty general question. So I assume things like certificate generations or I don't know.
Yeah, and I could say with my work on the managed service, the tool suite is really OpenSSL commands and some of the command line utilities you have just for TLS in general. It's typically something that application developers hate, and unless you actually like TLS as a topic, it's going to be burdensome. But the the Aerospike uses the OpenSSL libraries, and so the OpenSSL command line utilities provide a lot of functionality, including benchmarking algorithms, and you can actually connect to a server as a client, so you can actually see the TLS handshake if you're trying to troubleshoot that. So that's a really good tool chain to use for troubleshooting TLS.
Thank you. So the next question, when using Vault, how is a secret associated with the user role?
What's the secret? So in the case of Vault, so there's kind of two ways you can use Vault. So we're like running short on time here, so I'll be quick. But basically, when you're using Vault for just secrets management of the keys and certs and stuff on the server side with a direct integration, that's one thing. If you're using Vault to do dynamic credential management, so Vault is creating the users and passwords for an application, for example, there's a middleware component. So with Vault, I think they call it a secrets backend, something like that. That is actually creating the user in Aerospike using Aerospike's APIs, and it would be creating the groups or the roles that user is associated with.
All right, thank you. So yeah, and if there's more details needed, so you know where to reach us. You can reach us on support or in the networking section of the summit, so we can discuss those things a bit more. So I think we're running out of time. So thank you, and I hope you guys all enjoy the rest of the summit.
Thanks for listening.